breakouts up here now, we're being asked to see is, are they linear or non-linear? What do we think about A? Is this linear or non-linear? Non-linear. What about B? Ooh, chunky pen. Holy cow. Let's try that again. So this one is non-linear. Okay, I'm just going to put NL because I am lazy. I fully support abbreviating as long as it's clear. Don't put L for both of them. What about B? What do we think about that one? It's linear. We got non-linear. We got linear. Ta-da. Moving on with our lives. We're just keeping it really short so that we make sure we have plenty of time for all the things we need to do today. Okay? Questions on either of these two? Huzzah. We're going to be in our notes. That's the extent we're doing with those. We are going to be on page 8. See what it says. And it should look like... Okay, that's imagery. It's at the bottom of the page we started yesterday. So our extrema page at the top, or our even, odd, or neither at the top. And then we're going to look at the extrema down here. Extreme. Yes, Jim. Another packet? Yeah, give me a second. Put this in here. Because otherwise, if I don't put it in here, I will lose it, and then I will be irked at myself. I always keep extras of everything over here, whether it's homework, pages, note packets, everything. So if you guys ever need one, I always keep extras. I understand. I am ADD. Clearly, y'all have seen me for a week. You can tell that already. So I lose stuff constantly. So I keep extras always. So no judgment ever. I always keep PDF copies up on the Canvas page. Videos are posted. So however we need for making things up, it's there. All right, so what we're going to talk about today are called extrema, which means they're kind of extreme, hardcore, extreme. All that means is if we're looking at our graphs, and especially when we start looking at the wiggly squiggly looking ones, like these kind of guys, we're looking for our highest points and our lowest points, the extremes on either end, whether it's highest, whether it's lowest, mountains and valleys. So we're going to write out these words and what they mean. So we've got extrema here. That's kind of our vague definition. It's kind of like our title. What it means for something to be an extrema, or what extrema are points that are the locations of relatively, there we go, high and low points, or high and low values. Or another way to kind of think about it, it's where our graph turns. So where it goes from going up to going down. Where it goes from going down to going back up. So where it's changing directions. So I'm going to put that over here. Graph changes direction. So we can find all of our extrema if we figure out every place where it goes from growing to shrinking or from shrinking to growing. Wherever it turns, there is where we have an extrema. So if I'm tracing my line every time I twist my hand, that would be an extrema. And then we have 4 kinds of extrema. We've got our maximum or our minimum. These are also called the absolute maximum and the absolute minimum. And then we've got our relative maximum, relative minimum. So if it just says maximum, that can also mean our absolute maximum or absolute max. Again, you do not have to write the whole word maximum. You can put max. It's totally fine. It is clear enough. So our absolute max is the very highest point on a graph. Like the ever highest, ever, the tippy top it ever goes is the absolute maximum. It is absolutely the highest. Absolute max. Tippy top. Which gives us a little context on what we think the absolute minimum might be. Same thing, but instead of highest, lowest. So our absolute minimum, or absolute min, is the very lowest point on a graph. So we have a definition we're going to put down for our relative maximum and our relative minimum. What those are going to be is, if we think about maximums, if they're the very highest point, they're always going to be something kind of like a mountain. So they're always going to be kind of the tip of it. If there's another little baby mountain, smaller than the absolute maximum, but still kind of a mountain, that's when we're going to have a relative maximum. It's the maximum, but only of its little neighborhood. So this is being like, it's the queen, and then this would be like the queen of the building. So, important. Still important, but just not as big. So our relative maximum, the way we're going to word that, there we go, changing colors. Which a lot of times we're going to abbreviate as just kind of the RMAX, just because both words are annoying to spell. So our relative maximum is a point on the graph that has a larger y value than the points to either side, than either of its neighbors. And I know this makes this definition really long. And points to either side. So again, this means it's got the highest y values, so the points on its right side have lower y values. The points on its left side have lower y values. It's a little mountain. Should always make a little mountain. It might be a very small mountain, and then it might go whoop again, and then go back up. But it's making a little mountain. Even if the other sides of it go all kinds of wonky. Little mountain. So relative maximums are little baby mountains, which means relative minimums will be little baby valleys. So a minimum, our absolute minimum is going to be the very lowest it ever goes. And if we have a relative minimum, it's going to be that we have a little valley somewhere. It might not be the lowest it goes ever. My arms do not bend like this. Might not be the lowest it goes ever, but it is a little baby valley. So minimums and relative minimums are all kind of valley-looking things. So our definition is going to be almost the same as our relative maximum, just lower instead of higher. So our relative minimum, which again we often abbreviate as R min, just because both relative and minimum are annoying to spell. I am seeing the head dance in the back row, so give me a second. Just making it so we're not all the way on the bottom for my friends in the back, and I will zoom it out so we can see all of them in just a second. Our relative minimum is a point on the graph that has a smaller y value to the points on either side. I'm gonna just go out so we can see all of them. There we go. Just trying to make it so my bottom one isn't all the way on the bottom. Especially my back row. If I ever need to move things up, please, please, please let me know. I stand right next to it. There's nobody blocking me. Let me know. Again, same thing with colors. If I ever write something in a color up here that you're going, I can't see it, let me know. It's easy to change. From this angle, I can barely see that the screen is on, let alone how well it's showing you stuff. I want to see the pictures. I have to go like this. Okay. Questions on any of these definitions? That is the most amount of writing we're going to be doing today. Okay. Try and get all the writing done first, because stress. So we are going to look at the pictures on the next page. There are 3 graphs. We are going to find our extrema on these 3 pictures, and then we're going to do our little quick skills check thing. Okay? So, means we're going to be looking for our tippy top points and our very bottom points. So, we're starting with 2 kind of simple ones. I've got them both up here on the same screen. I'm going to change my view so we don't have that black border on the top because it feels so wasteful of space. There we go. So, we want to know what kind of extrema it has and where it is. We will not have all 4 extrema points for pretty much any function. Usually it has an absolute maximum or an absolute minimum. Very rarely will we have something that has both a tippy top and a tippy bottom. That's, an actual point. There will be times that we have relative maximums and relative minimums, and we may have bunches and bunches. There should only ever be 1, maybe 2 absolute maximums or minimums. And very, very rarely will we have both in the same function. So let's look at this first one here. We've called it f of x over here. Well, technically the book called it f of x right there. That's how we say this, by the way, f of x. This one is g of x. But if we look at this guy here, we want to see if we can find out the very, very highest point, if it has one, or the very, very lowest point, if it has one. What do we think? Does this have a absolute maximum, or does this have an absolute minimum? On just this one. It has an absolute minimum. What is the very lowest it can go? How low can it go? About -5. Its very, very lowest it can be is here. It's never, ever, ever in the entire function going lower than that dot. So this has an absolute minimum. We're going to put absolute min. It is the very lowest it can go, and we are going to write them as ordered pairs. So this is at the point 0, -5. Remember that our ordered pairs are always written x, y, every single time. Super duper important. That I am petty about. We can find these points if we think about this being where we change directions. If I read this graph, we're going to go down, 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 and then it switches to go up, 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 up. So where it switches from going down to going up is where we're going to have an extrema. Whenever it changes its direction, we have an extrema. So whenever we have a U-shaped one, we're only going to have 1 point. It only changes direction 1 time. So however many times it changes direction is how many extrema we have. So on this one, it's going to go up, 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 and then it switches and it goes down, 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 and then it switches and it goes up, 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 up. So we're going to have 2 extrema. Wherever it changes direction is where we have our extrema. So we're going to have one, instead it's going up, 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 and then it switches to go down. So we know there's going to be something here. And then it went down, 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 and it switched and started going up. So we're going to have another point over here. So we're going to have 2 extrema on this one. We just got to figure out what kind they are. I feel like the purple one's a little bit easier to spot it out. So this purple one right here, is this a maximum type or a minimum type? It's a minimum type. We've got a valley here, right? It is as low as it goes. Right there. Is this the, that's your face. Is this the lowest it goes ever? I can see right here, it's going lower and lower. This is the lowest of its little neighborhood. If I was to zoom in real far, like that, it looks like a low point. It's a valley. It's a bottom. It is as low as it can go in that area. So it gives us minimum-ish. It's just not absolute minimum. So that is a relative minimum. It's relatively low. So we're going to have a relative min, which we tend to put R min. And we're again going to put it as a point. The x value is 0. Our y value is 4. So then let's look at that green one up there. What kind of point do we think this one might be up here? Oh, it's a relative maximum. It's a little harder to spot because these 2 pieces are so close together. But this it's a little mountain, so we have a little maximum. Push your face. So we have a little maximum, but this arrow is pointing up, so this keeps going up and up and up and up and up and up and up. It only stopped because we stopped printing graph here. So it keeps going up. So this is not an absolute maximum, it's just a relative maximum. So we're going to have times when we don't have absolutes, and that's okay. This is a relative max, and it is at the point, what is our point on this one? -2, 8. Perfection. All right. Okay. So then we really only have one more graph that we're looking at. It just has many choices for us. So we're going to look at several of these pieces, and we're going to think about them in context as well. Okay. So again, we've got a lot of information up here. We've got our x's are set as hours. Remember, if we've got a unit of time, that's going to be our x. So hours is our x. So it's hours since midnight. And then number of posts. This is a vague contextually social media like weather map. How many people post? So we have a lot of places where it changes direction here. What's one of these places that we've noticed? We've got a lot of points up here. What is the very highest point we see on this graph? Do we have an absolute maximum? Where? 12, and then up here, probably 11.5-ish. So we know that at 12, 11.5, whether you want to put that as 11.5 like this, if you want to put it as 11.5, if you think it's, I don't know if it's 0.5, I think it's 0.4, 0.3, 0.2. Get it close. When it comes to the decimal points or the fractions in graphs, we are estimating, and so that means I am not going to be petty to be like, Well, you said it was 0.5, and I think it's 0.4, so wrong. I'm not that petty. As long as between 11 and 12, we're good. So this point is our absolute maximum. Oop, that's not what I meant. So you can either call that just the max. That's fine. You can just plain call it the max. It is the maximum. Absolutely. Absolute max. Or you can say it's a max. You can write out the word absolute if you want. Absolute max. But if you just put max, I get the point. Just don't tell me max and then give me like 4 points. Because what is this telling us? 12 watts and 11.5 watts. 12 hours after midnight, there are 11,500,000 posts-ish. Right here. Not even something I touched the screen with. So at 12 hours past midnight, also known as mu, is where we have our highest point. And you can put that in your context if you want to, or you can just say at 12 hours past midnight, that's our label. So like this, hours past midnight is because that is what it says down here, hours past midnight. Since we have our maximum, we can say that it's the most social media posts, which social media posts happen. It's the most. Because we're at our maximum, because we're at our absolute maximum, we know it is the most. It has the most. As far as the context, you can also just put up, just like we did before, at 12 hours past midnight, there are 11.5 100,000 social media posts. Totally fine. You can do the plug and chug just like we did for context the other day. So we have a few other extrema to notice on here. I'm not going to write out the full sentences of context on the rest of them. I just wanted to see how we could work our extrema in. So we know we've got our absolute maximum. Do we have an absolute minimum on this one? I'm going to put out this arrow. Shut your face. This has an arrow, which means this does technically continue on. So do we have an absolute minimum? No. Because we have some low points. I've got some valleys. But my arrow tells me this goes lower. So the arrows continue it off. That's your face. And I'm going to turn it off. Now I can touch it without whining. Grumpy. She's grumpy. It's okay. So we know we don't have an absolute minimum, so we don't need to put that down. What other kind of extrema do we have here? We have a relative minimum. Where do we have a relative minimum? At 14. Yeah. Up here, it's a little valley. So we have relatively a minimum. If I blocked out all these things, it is the lowest point of any of its neighbors. So that does count as a relative minimum, even though it is higher up than a good chunk of this graph. It still counts as a relative minimum because it's a little valley. So we're going to have a relative minimum at our point 14, 9. So there's a dip in our social media points. Posts, not points. There's a dip in the social media points at about 14 hours after midnight. or at 14 hours after midnight, there are 900,000 posts, which is low. What other extrema do we have up here? We have a relative maximum. Where's our relative maximum up here? Because we have our absolute max. We've got a relative max. 16 and 10. And if you want to make the argument that maybe it's 10.2 because it's slightly above, that's fine. Go for it. Label it what you want. Just don't tell me it's on 11. So we're going to have a relative maximum at our, I forgot the points, 16, comma 10. So there's another peak in our social media posts here. So there's another surge at 16 hours since midnight, which is about 4 p.m. And then we have one more here. Where do we have one more extrema? Think about tracing it, seeing where we changed directions. So we went up, changed to down, changed to up, changed to down. Where do we change again? About 4, 2. And again, if you want to argue with me and say, I don't know that it's right on 2, maybe it's at 1.75, fine. I'm also okay with us rounding on this. I'm not super petty about that point. Just don't tell me it's at 2.4. 4.2, totally valid. 2.4, not so much. Okay? So we have another relative minimum, because it's in a valley, at the point 4, comma 2. And again, if you want to put that as 4, comma 1.8, totally fine. 1 3/4, totally fine. 2, totally fine. Just don't flip them. Okay? I'm fine with us rounding and estimating. If we want perfection, we will be using computers because we are good at graphs. Computers are better at graphs. When we are looking at or making graphs, we're getting the vibe. We're getting an ish. We're getting it close. Because we are not as good at computers at drawing. For sure, I am not. Okay? So extrema is our little mountains, our little valleys. Peaks and valleys. Questions on those? Because that's what we do with our extrema. We'll talk about extrema again next week. We're going to keep using them. They're going to be parts of what we're going through as we continue on to the next stuff. But before we plow through the rest of this chapter, we are going to do a little skills check. So you're going to treat this kind of like a baby quiz. It does not go in as a quiz. It's going to go in as a homework. But this will let us know how we're doing and all the stuff we've done before today. There's not extrema on this. This has our domain and range, continuous, our linear, our nonlinear, intercepts, that kind of stuff. So we're going to do this kind of like a practice quiz on homeworks, which I will pass back to you as you guys are getting finished up. I'm going to pass them back. On homeworks, I very rarely grade every single question. In fact, I don't think on anybody's I graded every single question. I kind of spot check stuff. So I post the answer keys for these when I hand them back. So these answer keys are going to go up today. But on skills checks, I will grade every single question and I will write feedback on them. I have the time to do it once a chapter. I do not have time to do it for every single homework. So I will give you way more feedback on these than I do on homeworks. So we try and do one of these before every quiz or test so that we kind of see what we need to work on. So that's what we're going to do pretty much for the rest of the time. I'm going to give you guys this. I was like, I don't think you need the whole rest of the time because we have 15 minutes. I don't know that you'll need the whole time, but you have it if you need it. When you are done, it turns in the turn-in bin. The big bucket that says turn in. Everything turns in here. Homework, spell work, quizzes, skills checks, everything. Everything. If you put it on my desk, I make no promises of its continued existence. Because it does turn into a black hole. Okay, so I'm going to put this up. If you have questions, if you don't know what the question is asking, let me know. I can always talk you through it or reword something. Okay, so give these a try. See what we can do. see how we're feeling. We've had a couple of homework to try these things. Give it a shot. See what we got. If you need anything, let me know. I'm happy to help. If you need that tracing paper stuff, if you need a different pencil, if you need eraser, a calculator, let me know. Shouldn't need a calculator, no calculation on this. Okay? Let me know how I can help.
Let me know. Thank you. We are just getting started on this. Let me get this going.
Change the screen. There we go. That's where we are. Yes, dear.
Since these are like two separate ones, am I supposed to look at a certain one for which one I'm looking at?
Do both for both. So do domain and range for this guy, and then do domain and range for this guy. And I can give you a closer note to cover that if you want.